Here's problem 810. A pendulum is made by letting a 2 kilogram object swing at the end of a string that has a length of 1.5 meters. The maximum angle the string makes with the vertical as the pendulum swings is 30 degrees. What is the speed of the object at the lowest point in its trajectory? Alright, let's imagine we have a pendulum and it swings down from a 30-degree angle. Length is 1.5 meters. And what we might be interested in is actually the difference in height it has from its lowest point. So we'd like to find out this height here. It's not easy, but if we look at the full length, and if we were to subtract the side of this triangle that is along that length, then the difference between those two would be equal to h. In other words, looking at that triangle, that length that comes down this way is equal to L cosine theta, where theta is the angle of the from the vertical, and hence h is going to be equal to the full length L minus that length L cosine theta. Full length being all the way down to the bottom. So in this case, that's going to be equal to 1.5 meters minus 1.5 times the cosine of 30 degrees. And what is that? It's 0.201 meters. Since we started from rest and we went without friction to a lower height, we can use our quick formula for our velocity at a lower position. That's the square root of 2gh. That applies for that special case where you start at rest, go down to a lower height, and acquire a velocity. So in this case, that would be 2 times 9.8 times 0.201, all that square root. And what is that? 1.98 meters per second. So that is the speed of the mass when it reaches the lowest point in the trajectory. If you don't like that, you can go through the full conservation of energy problem between A and B, and you would say that the kinetic energy at A plus potential energy at A plus any work done along the way equals kinetic energy at B plus potential energy at B. In this case, kinetic energy at A is 0 because we started from rest. Our work done along the way is 0 because there is no external force on it. And we'll define our potential energy at B to be 0 because that's our lowest height. So we'll define that as being 0. So we would have that mg, height at A, equals 1/2 mass velocity of B squared. Getting rid of the mass on both sides, we have that the velocity of B should equal 2g height at A square root. And that's where we got that equation. So indeed it's 2 times 9.8 times 0.201 square root 1.98 meters per second. So that's our answer, 1.98 meters per second.